We use scientific notation when we're dealing with numbers that are really big or really small. It just makes it a lot easier than writing it out in standard form. Now these first couple are kind of easy, so you ask yourself, well, it makes more work, but no, just get used to writing them, because someday you're going to have 10 to the 23rd as your exponent, and that's when we deal with number of particles. So I want you to be able to use the exponents before we get there, so that when you do get to those big exponents, it's not going to scare you. So scientific notation is just based on place value. If we look at the place value, here's a decimal, right? We would call this the tenths place. We'd call this the ones place. This is the hundredth, this is the tens, and the hundreds. All of these are based on the number 10. So 10 is our starting point. If we have 10 to the first, we have 10, and it would be this place here. If we have 10 squared, it would be 100. It would be this place here. See? This number with 2 zeros would have 10 squared as the place value. And then if we're dealing with 1, the ones place is just 10 to the 0. 10 to the 0 is 1. Any number to the 0 is 1. And then 10 to the negative 1 is 1/10. And 10 to the negative 2 is 1 over 100. So when we go down on our exponents, when we divide by a 10, we actually subtract an exponent. When we divide by a 10, here, we're just dividing by the 10. So this should help you see where the place values are. Now let's go ahead and look at our problems and see how we can use that. This number is less than 1. So we know that it's going to have a negative exponent. This number can be written as 5 times 1/1000ths. That's what that number is. And this 1 over 1,000 can be written as 10 to the negative 3. So it's the same as 5 times 1,000ths, or 5 times 10 to the negative 3. This one only has one extra 0 there. We just want to get rid of the extra zeros. So we could say it's 505 times 10. But the problem with that is that we just made more work. So usually scientific notations has one whole number in the ones digit, the ones place value, and then the rest are decimals. So let's rewrite this as 5.05 times 10 cubed. Because it'd be times 10 to the 1,000. Times 1,000. This one is less than 1 again. So we have to move it over. Well, how many places do we move it over to make a whole number? We have to move it over 4. So it'd be 8 times 10 to the negative 4. This one has 3 places, so it'd be just 1 times 10 cubed. This one has 6. 1 times 10 to the 6th. And don't forget, when you're dealing with metrics, the prefix for 1 times 10 to the 6th is mega. This number is less than 1 again. So it'd be 2.5 times 10 to the negative 1. Because it'd be like 1/10 multiplying by 1/10. This one would be less than 1 again. 2.5 times 10 to the negative 2. This one, negative 1 again, and we move it over 3 places. 2.5 times 10 to the negative 3, because we moved it over 3 places. Remember, these correspond with places. These are all place values. This is like 5 times 10 squared. And this one is 5 times 10 cubed. Again, you're just practicing using these simple numbers, but later on you're going to be doing big numbers, so you're not going to want to change back to standard form, because the scientific notation is so much easier. In this next section, what we're going to do is we're going to write it in standard notation. So number 1, we have 1.5 times 1,000, because 10 cubed is 1,000, so that equals 1,500. Number 2 is 1.5 times 10 to the negative 3. So this tells you that you actually have a number that's less than 1. And how many places? We got to move it over 3 places. So here we move it over 1, 2, 3, and then just fill in zeros for those. So it'd be 0.0015 because we moved it over 3 places. Number 3, we're moving it over 2 places, and again it's less than 1. 0.0375. This one is bigger than 1, greater than 1, it's 100, so it'd be 3.75 times 100, which is 375. This one is times 10 to the 6th, so it'd be 2, 1 place, 2, 3, 4, 5, 6 places. The next one's kind of hard to read. I think it's a -1. So it's 3.35 times 10 to the -1, so we just move it over. So it'd be 0.335. Number 7 is times 10 to the -4. So it'd be, move it over 1, 2, 3, 4. 0, 0, 0. So it'd be 0.00012. Because we have to move it over 4 places. Number 8 is 1 times 10 to the 4th. 1, 2, 3, 4. Number 9 is 1 times 10 to the -1. -1 makes it less than 1, so we just make it, bring it over, so it'd be just 0.1. 1 times a tenth is a tenth. 10 to the 0 is 1, so it'd be 4 times 1, which is just 4. I hope this helps you. I'm going to show you the number that we deal with a lot. Whoops. And that's Avogadro's number. That is 6.022 times 10 to the 23rd. That is equal to 1 mole of something. I like to liken this to a dozen. If I say I have a dozen of something, you know I have 12. Well, here, 1 mole of something is just 6.022 times 10 to the 23rd. And you're not going to want to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 places. After that, 6 every time because we use this all the time. So getting to know scientific notation really is a lot of help, and it's not really that difficult. So if you have any other trouble, please come and see me. But for the most part, I think it's pretty self-explanatory. It's just according to the place values. Have a great night. See you tomorrow.